So we're saying, first off yesterday, make sure you understand that R of t is a rate of change, right? So it's mosquitoes per day. So if you plug a number into there, it tells you how many mosquitoes per day you're either gaining or losing. It's positive, you're gaining mosquitoes; negative, you're losing mosquitoes. So the very first question says, show the number of mosquitoes is increasing. And all you're going to do is, that always has to do with the derivative, but because R of t is a derivative, we said we just want to find R of 6. Okay, whether or not it's positive or negative. Now, you can do that in a calculator. So just to review all that junk, we're going to go to y equals, and we're going to put in this function so that we don't have to really, let me move this over some, mess with it too much. So we're going to put in 5 square root x, boom, what cosine, x over 5. There we go. Okay. And if you want to put in 6 into that, you just hit vars, go over to y vars, whoops, y vars, you can do it. What just happened there? It's not funny. Y vars, function y1, there we go, of 6. Kaboom, and you get that. Everybody cool with that? Did we do this yesterday? I can't remember.
Yeah.
All right.
We got that.
Okay. So we get 4.438, which we just to recap here, 4.438. And we said the units on that are mosquitoes per day. So then you're going to write something along the lines of the number of mosquitoes is increasing. I'm not going to write it right now, but the number of mosquitoes is increasing because R of 6 is positive. Huh? Okay. Easy enough? So B. Again, you'd have to write that sentence here. I'm kind of skipping it. For B says, show that it's increasing, which we know already, at an increasing rate or a decreasing rate. Okay? And we say that just means you got to check really the second derivative of the amount of mosquitoes. But since R is the first derivative of the amount of mosquitoes, then we just need to check R prime of 6. And we can show you how to do that on a calculator too, right? That's math 8. And you put your function in that you want to derive. Boom. If you got the newer stuff, this is a little bit easier, but comma x, comma what, 6? There you go. And you get negative 1.913. And that's in mosquitoes per day squared. Okay? So those are two pretty straightforward questions. That's how you're going to find a lot of these free response questions are. First couple parts, not too bad. And then C asks us how many are there going to be at time equals 31. And yesterday we talked about if you know the derivative of a function, in this case the amount function. So that's probably the first thing I would have done for this question, like in general. I would have made up a function called A of t. And I said A of t equals the number or the amount of mosquitoes. Is there an E on there, you think? Did I ask you this yesterday?
There's an E.
Cool. At time t. Okay? So A of t is this new function now, and we know that the relationship between A and t is that A prime of t is R of t. That's what they gave me. Okay? They didn't call it A prime of t, they called it R of t, but it's still a derivative of the amount, because it's the rate of change. Easy enough? And we said if you're given the derivative and you want to find an amount, you always write it out like this. You take the y value you know, which in this case is, we know there are 1,000 mosquitoes initially. So we start with that. So A of t equals 1,000. And to that, we're going to add the integral from when you know it's 1,000. In this case, it's 0. And we're going to go all the way to t. So for this question, we want t to be what? We want it to be 31, right? So we're going to integrate to 31. But right now, I'm just writing an expression just for A of t in general. So to find A of any number, we need to integrate from 0 to that number. And we need to integrate its derivative, which is r. And then you can't use t again down here. You got to use a different variable. So you should use x. Okay? So that right there is an expression. Now I can find the number of mosquitoes at any time, as long as I just do that. Now we can't integrate r by hand, but the calculator can. So we're going to let the calculator do all the heavy lifting here. But all we need to find is what's A of 31. And because I'm going to put this exactly in my calculator, I'm going to write it out. Cool. A lot of times on the AP exam, you get points for showing what you've done and then for the correct answer. So if you mess up on your calculator or something, you forget your degrees when you're supposed to be in radians, write out what you're doing at least, and you still get like partial credit. Okay? Also, if you just do it in your calculator and write the answer down without showing what you did on your paper, you might just only get half credit because you didn't show what you did, even though you got the right answer. All right? So anytime you put something in your calculator, write out what you're doing. And for this, you put this in just like it looks. if my, maybe I need more RAM here. Yeah, you think so? What the heck? Come on, calculator. Well, anybody know what this number is? What is it? 964. 0.335. Now, does this one say specifically to the nearest whole number?
Yeah.
Okay.
Yeah, so you round it.
Cool. So you don't want to put that there. Generally, again, we want to be 3 places accurate. But if it says round to the nearest whole number, do that. And this is just in mosquitoes. Okay? And that's the answer to that. They don't ask us to explain that or anything. You just got to show what you did. Cool? And then D says, yeah.
Did we get this paper yesterday?
Yes.
Like that?
Yeah. Okay. So, okay. D says find the maximum number of mosquitoes, which means we want to find the maximum of what function right now? Now, we don't want to maximize R, we want to maximize A. A is our number of mosquito function, right? We want to maximize A. And the very first thing we do to maximize something is we find out where the derivative is 0. Okay? So, we need to find out where A prime of t, which is R of t. You don't have to write it like this, but I am, just so you know we're doing a derivative here. Okay? But you don't actually have to derive anything, which is the nice part. They already gave us a derivative. We've got to find out where that's 0. And I'm going to do that on my calculator by graphing it. Okay? So you don't really show any work. You just got to show I'm finding where R of t is 0. And you're going to write that happens at t equals. And I still, hey, it worked. So remember I put in R of t in my calculator already. And we're only looking for the interval from 0 to 31. So I'm going to change my window. Before I graph this thing crazily, I'm going to graph from 0 to 31. Because that's my time interval I want to see. And all I really care about is when this thing hits what? 0. That's it. All I care about is 0. Okay? So I'm going to count on my x scale by tens. Just because I'm going to 30, so that'll be an easy thing to see. And I'm going to let my y scale just go from like a -1 to 1. Or -1.5 to 1.5. As long as 0 is in your interval, that's what we want to see. Okay? You don't need to see the whole graph. We just got to see where does it hit 0. So now I'm going to graph it. And there's 1. And there's 2. Okay? Now because this is a derivative, you guys see what's happening here? As I move along this curve, my derivative is changing from what to what at that first 0? Positive to negative. Which means that first 0 could be a, if the derivative changes from positive to negative, there's a relative max there, right? Now we're looking for the absolute max, which is different. That means we've got to find the highest point in general. Cool? But that is a relative max. The second one is going to be a relative min, which means that second number we really don't even care about. But on the AP test, you've either got to check all the zeros or explain why you didn't check some of them, if that makes sense. Cool? So, and I'll show you how to write this a couple different ways, but if you're ever confused, just check all the zeros. You guys remember we did this way back when we were doing EVT. We found the zeros of the derivative, and we found the y value at those numbers and at the endpoints. Okay, and if you don't remember that, that's how we're going to do it. But we got to find these zeros. The answer key online tells you they're 2.5 pi and 7.5 pi, right? Something along those lines. You guys do? Yes? Did I look this up? No? Okay. Well, they tell you they're like in terms of pi. You don't need to know that. We just need to find these decimals like on this calculator. And the way you find zeros is you hit second, trace. You want to find that 0. And that first one looks like it's around like 8. You guys see that? Yeah. So I'm going to say, hey, look between 5, enter, and 10, enter. Look around 8. Great. And we're going to get this number, 7.853. Okay? You guys should be following along with me if you're calculating, by the way, but I see a lot of you aren't. That's okay. I'm going to show you some shortcuts here. So because we have to use this number right here, which we have right now out to what, like 7 or 8 places. Okay, we have to use that number to get our final answer at this point. Okay? So I can't round this number. So on my paper, what I'm going to do, because I don't have to write this stupid number over and over and over again, on my paper, I'm going to write R of t equals 0 when t equals, I'm going to call it A. Actually, we already used A for our function, so I'm just going to call it B. Okay, I'm going to call this number B, and now every time I use the letter B, it's going to represent that number. Okay, and I'm going to write out what B is. It's 7.853. Uh, 9816. What do I want to do with this number, by the way? You guys with me on here? Plug it into what function? A. A of t. We want to see what's the number of mosquitoes there, because we want to see, is this a maximum? Okay? But we're also going to find that other 0, which we already know it can't be a maximum, so that's fine. But let's just find it anyway for right now, and again, I'll show you how to write this out. Okay? But we're going to find the other 0. It looks like it's like 22 or something. So we hit second, calc. Oh, wait, crap. Before you do that, sorry. You know how we just found that x-intercept, 7 point whatever? Your calculator stores that as the answer right now. So if you quit out of here and go home and you just hit, you know how you can hit second answer? It has that number saved. So you don't have to type this in over and over again. All we're going to do is store it as a letter. I'm calling it B. So the way you do this is, right after you find the intersection, the x value, you hit store, which is right above on, and you hit alpha B. And that's just going to store that number as the letter B. So anytime I want to call that number up, I'm going to just put B in my calculator and it's going to do it for me. Everybody good? But it has to be right after you find it, otherwise it'll use a different answer. Okay? And then I'm going to go and find the other 0, and I'm going to call that something like C or something. Cool? So I'm going to go back to the graph. I'm going to find my other 0, which looks like it's around 22. So I'm going to say look between 20 and 25. And I'm going to guess 22. And it is 23.56, so we're going to write that down. And I'm going to write that's C, okay? So I'm solving this equation, but I'm calling them these letters so I don't have to write these numbers over and over again. Don't forget already. 23.561. Uh, 945. Cool. Also, you see how it says y equals this weird number, negative 2.43 e negative 12? What's that really mean? My calculator is telling me. What value is that? Yeah, so it's 0.0000000000243. Okay, I hope that was enough zeros, but it's really just 0. There's just some rounding error. There's a very small rounding error, so that's why. Remember, we found the x-intercept, so the y value should just be 0 exactly. There's some rounding error. That's why they're giving me that weird little bit of change. Okay, but that just means 0. But when you see a number e to a negative big number, that just means 0 basically for us. Okay. So anyway, I'm going to store this as C. So I'm going to quit out of here. I'm going to hit store, alpha, C, enter. So I've got them both saved. We're all good? So notice the wording of this question, okay? Because you're going to see this at least once on the AP exam here. To the nearest whole number, what's the maximum? So we want to maximize something. Show the analysis that leads to your conclusion. Nowadays, they'll say justify your answer or explain your answer. And the way we justify that we know we found the maximum is we need to do really just one big thing here. So really two things. You got to find out where the derivative is 0, because that's the only place a max could happen. That makes sense? The only time a function could have a maximum is if the derivative is 0 or undefined. Okay? Or where else could a 0 or could a maximum happen? If it's on a closed interval. At the endpoints. So the maximum is either at one of the endpoints or it's at one of the zeros of the derivative. Well, we found both the zeros of the derivative. We know what the endpoints are. All we got to do is find out how many mosquitoes there are at all those times, and the maximum is just the one that is the biggest. Okay? So all I'm going to do down here now is I'm going to say what's A of 0, what's A of B. I can use B because I said what B was. What's A of C, and what's A of 31. We're going to find all 4 of them, because they're the only possibilities. We already know A of 0. They gave it to us in the beginning of the problem. 1,000. We already know A of 31, because they made us find that in part C. What was that, 964 or something? 964. So the only things we got to find now are at B and at C. Okay? And we're going to use our function A of t to do that. We got to find the amount at those times. So, if you remember, and something you can do here to make this easier for yourself is you can put what A of t is into y2, or you can just type the thing out on the home screen. I'm just going to type it on the home screen for right now. So we know A of t was 1,000 plus the integral, which is in my calculator math 9, of what function? What can I put here on my calculator? R of t, which I put in as y1. So I'm not going to type it again. I'm going to say y1 in there. So vars, y vars, function, y1. y1. Okay? I want to integrate from, well, I got to put x there. I want to integrate from 0 all the way to b. If I want to find out how many mosquitoes are at b, I got to integrate to b. So now I'm going to hit alpha b. There needs to be a comma there. Comma, alpha b. There you go. That's going to tell me how many there are at time b, which we expect is the maximum because that's when the derivative is going from positive to negative. Okay? And we get 1,039 to the nearest mosquito. So at time b, there's 1,039 mosquitoes. Okay? And then we got to do the same thing for c, and check out this little shortcut as well. We could type this whole thing in again, but if we just typed it in last time, if you hit second enter, it puts the same exact thing we just typed right there. On the newer ones, I think you can also copy and paste, right?
You can just go up.
So you can go up and hit enter, that's fine. But second enter also does that for you. And then all I got to do is go back and change. I don't want to integrate to B, I want to integrate to C. And look, we should, again, we expect this is going to be a smaller number because the derivative was negative leading up to this. So we should have had a decrease in mosquitoes. And if my old calculator can handle this, we're going to get 842. Okay? And now you don't have to explain what you did for calculus, okay? All you need to do is show you found the zeros of the derivative, you check the endpoints, and you check those zeros. Cool? Because they're the only places a max can happen. And then you just write a sentence explaining what you did. Okay? So I'm going to type mine up because I'm lazy. And I'll play writing this out in my chicken scratch. But, you ready? You're going to write. Answer the question. The maximum number of mosquitoes is 1,039 at time B. Are we measuring time in what? Days in this one?
Yeah.
Okay. So if you're answering this question, sometimes they'll ask when is the max, sometimes they'll ask what is the max. Cool? To make sure you just don't like answer the wrong question, just put both. Say the max is this and it happens at this time. Everybody okay with that? And then all you got to do is explain what you did a little bit. Ready? I checked. What do we check? The endpoints and where zeros of or where r of t equals 0. Cool. If we didn't check c, because we knew c was a minimum, right? We knew c was a min because the derivative was changing from negative to positive there, right? So if that was the case, we'd write the same thing, the maximum number of, so you don't write both of these. I'm saying if you don't want to check c for whatever reason, you could write it like this. The maximum number of mosquitoes is 1,039 at time b days. I check the endpoints, and specifically where what? Where r of t changed from positive to negative. Okay? That's if you just check B. But it's really not hard to check C, so why not just check it anyway, you know what I mean? Just to double check. You know it should be a minimum, but every once in a while you make like a little mistake or something. Okay?